Hi everyone, so this is a Born Haber cycle video, how to make Born Haber cycles, how to build them, some tips, and then how we do the calculations as well. So in this video we're going to concentrate on lattice enthalpy, that's what the LE up here stands for, and we're going to look at what we do when we're building it to start with. There's going to be another video later for tricky ones, and we're just going to start with building our basic one. To start with. So, first things first, this is about lattice enthalpy. It's about making 1 mole of an ionic solid from its gaseous ions. So that's what we're going to do first. We're going to get that lattice enthalpy in. So get that ionic solid at the bottom there. And that's what lattice enthalpy is. It's all about that. So ionic solid goes at the bottom. And we're going to build up various reactions which are going to include this or work towards this or work away from it. So sodium chloride, ionic solid at the bottom. So if you remember your definition for lattice enthalpy, it's to make 1 mole of ionic lattice solid from its gaseous ions. So get those gaseous ions above it. So this is your lattice enthalpy here. Now in the lattice enthalpy, Born Haber cycles, this is always on the right. So we're going to get these ionic gases, the gaseous ions at the top here, and that's what the lattice enthalpy is. Sometimes you'll be told that value, sometimes that's what you've got to work out. I've simplified this. I'll have to break this down in a little bit more detail in a second. So these are your gaseous ions, and you can see that they are near the top. So your ionic solid at the bottom, gaseous ions near the top. There's usually not much above this when we do that. So next what we're going to do is we're going to fill this in and we're going to make it into a nice cycle, so all the reactions are going to lead from one to the other, just like the Hess cycles, but obviously you can see it's a bit more steps to it. It's really no more difficult, and you're going to become really good at these, and it's easy marks in the exam if you can do it, so please make sure you can master this. So we can see here we've got an ionic solid. We've done the lattice enthalpy equation, so that's basically from here to this bit here. So you can see that we've got sodium chloride. Now we can also do a delta H formation. So the delta H formation is this one here, and if you remember your definition from first year, 1 mole of a compound is formed from its elements. So let's get its elements up here. So elements in their standard states. So that's a solid, and this one here is a diatomic gas. We've only got one of it, so we need to balance it by putting that in. And if you remember the definition, 1 mole of a compound formed from its elements. So you're not allowed to have one of those and 2 of these, because then that doesn't balance, and it's not actually then delta H, because delta HF, because you're not making 1 moles of that. So the next step for this one here, you can see we're going to do 2 things here. Now I've just really summarised these 2. So this thing we're going to do here is, you can see that eventually we need to get from the sodium to the sodium plus and a gaseous. So we need to change it from a solid to a gas, which we call atomisation. We also need to get from a sodium to a sodium plus, which is ionisation. So there's 2 steps we've got to do there for that sodium: atomisation and ionisation. So let's do atomisation first. So that is this bit here, atomisation. So that's what we're going to do here. Now, we're not going to just atomise the sodium, we're also going to atomise the chlorine. So I'm going to put an extra, oh sorry, I should have done that in black. I'm going to put an extra line in here so you can see that. So first of all, we're going to atomise the sodium. So let's have that. Atomising it, if you look at the definitions, making 1 mole of a gaseous atom. So we're going to change that to a gas, and that's all we're doing. And the chlorine doesn't change, because we're going to do one thing at a time. So both these steps, it doesn't matter whether you do the sodium first or the chlorine, but you're going to atomise the sodium, you're going to atomise the chlorine, do one, then the other, and then you've got the atoms there, and then we can change them into ions. So this here is delta H atomisation, and that's of the sodium. And then we're going to atomise the chlorine, so delta HA of the chlorine. And this one here, so the sodium we've already atomised, so we can leave it as it is. And the chlorine, instead of being half Cl2, now it just becomes a Cl atom. It was already a gas, so we don't need to change the state symbol. So we've atomised our molecules and we've made them into both gaseous. We next just need to ionise them and get those charges on there. So that's what these two steps here are called. So this is the ionisation and electron affinity. That's for this step up at the top up here. So I'm going to get rid of this because it's looking a bit messy. So next we're going to, first of all, you need to pull off that electron off the sodium, and then once it's been pulled off, it can then be taken by the chlorine. So you have to do the ionisation before the electron affinity. So this is delta, in fact I'm not going to write delta H, I'm just going to write IE for ionisation energy. And of course it's of the sodium, because ionisation energy is about taking, removing an electron. So you have your sodium, it's still a gaseous, which we did down here, and now we've made it into a positive charge. So there we have our electron we've pulled off. Our chlorine hasn't changed, I'll just shove it on the side there. Then next, once that electron is here, it's roaming around loose and the chlorine just can't wait to get its hands on it. So this is going to be the electron affinity of chlorine. And it takes, you don't need to write anything here because you've got, nothing's changed with the sodium. That electron has been taken by the chlorine. It's a Cl minus. It was already a gas because it's chlorine and it was to start with. So now we have our gaseous ions, which is what we need for this. So that is the whole cycle. I'll just show you each of the steps. So formation is basically this bit here. So this is your formation, and it's from your elements in their standard form, making 1 mole of compound. And then you can see here your delta H atomisation. So all these 2 steps are atomisation. And that's this step and this step. First of all, of sodium, first of all, and then of chlorine. And then we do ionisation. We pull that electron off the metal, and there it is. You can see that. And then we do electron affinity of the negative ion. The chlorine takes the negative ion, and it becomes that. So these are your gaseous ions. This is your ionic solid. That's your lattice enthalpy. I'm going to do another video in a minute to put the numbers in for the calculations, just to keep these videos nice and short, and then you don't have to watch them all at once.